So in this example, we're going to be looking at standardized testing, specifically the SAT. Notice I've written our information down, but in a little different way. Remember, this little symbol right here means approximately. This right here tells us our average. And this right here gives us our standard deviation. So SAT score is approximately normal, average of 500, standard deviation of 100. This is per test, so per subject test. Now, what we want to do is answer a couple questions here. So first of all, what percent of people score below a 450? Notice, let's say you take the SAT, you get 450. You want to know, well, what percent of people did worse than you? Because I want to go ahead and find a percentage, I know I'm going to start by finding a z-score. To find my z-score, I take my actual, subtract off my expected, and divide it by my standard deviation. That is, I actually got a 450. I'm subtracting off the average of 500, and I'm dividing it by 100. Reminder, when you calculate this, make sure you put parentheses around the top. So that'll be negative 50 over 100, or negative 0.50. Notice it is a negative z-score, and what that tells me is I am below expectation, below average. Step 2, we're going to go ahead and draw it. So drawing my beautiful bell curve. It's actually not half bad. A little bit weird. Not bad, though. I'm going to go ahead and I'm going to put my z-score on it. My z-score, once again, is negative, so I'm below expectation, so in the bottom half. And then I want to know, based on this question, what percentage of people are below that? So I'm going to shade lower. So now that I've got that right there, I need to go ahead and think about this. Well, the z-table gives me lower end, which means in reality, I'm golden. This is perfect. I don't need to take one minus or switch anything around. I'm going to be okay. Step 3 then, I need to go ahead and use the table. And this would be a great time to pause the video, go find it on your own, and then check your answer. I'm going to go ahead and paste my z-table in. Now in this example, my z-score was negative 0.50, so I'll come over here. I'll trace negative 0.5 across, 0.00 down, and where they overlap, that will be my end tail. So I have probability of 0.3085. I'm going to go ahead and get rid of this. And because I have a lower end tail, I don't need to switch anything around. So the question, what percent of people score below 450? 30.85% score below a 450. Now let's go ahead and answer one more question with this. And so I'm going to ask, what percent of people were above a 670? So using the same information, we're going to go ahead and answer this question here. Once again, first step, z-score. When I calculate it, I'll plug everything in. 670 minus 500 divided by 100. That'll give me 170 over 100, or 1.7. Step 2, I draw it. A little bit uglier here. I'm going to put my z-score on there. A z-score of 1.7 means I'm above expectation, so in the top half. I'm going to shade it according to what I want in this question, and when I look at it here, it says I want what percent we're above, so I'm going to shade above. This means I'm going to have to be tricky about using my z-table. I'll either have to look at the negative and use that value, or I'll have to look at 1.7 and then take 1 minus it. So for step 3, we're going to go to the table, and I'll paste it in here. So as a reminder, you can either look at 1.7 and take 1 minus the value you find on the table, or if I'm looking for the percentage of people above 1.7, that's the same as looking at the percentage of people below negative 1.7. So showing it this method then, I'm going to go ahead and I'm going to reverse my z-score. So I'm going to look at negative 1.7. And once again, I'm doing that because I want to find the percentage of people who are above a z-score of 1.7. So I'm switching over to look at negative 1.7. I'm going to trace 0.00 down because it's negative 1.70. And what that gives me then is that this end tail right here is 0.0446, which means that if this table is 0.0446, this one has to be 0.0446 as well. It's symmetric. So, deleting my table, I can now go ahead and say that what percentage of people were above a 670? Well, 4.46% are above a 670.